In today's lesson, we'll start to dip our toe into the waters of deductive reasoning. And I'd like to start us off by maybe taking a look at the difference between deductive and inductive reasoning. First, the definition of the two. Deductive reasoning uses facts, definitions, accepted properties in a logical order to reach a logical conclusion. This is, in fact, Euclid's method. This is the axiomatic method that Euclid gives us. Compare that with inductive reasoning, which uses previous examples and patterns or experience to form a conjecture. And that's what we had been doing. Here's an inductive reasoning example. Nick knows that Drake is a sophomore and Cage is a freshman. All the other sophomores that Nick knows are older than Cage. Therefore, Nick reasons inductively that Drake is older than Cage. He's basing this on his past observations. This is an inductive conclusion, a conjecture based on inductive reasoning. Let's see how that differs. The deductive model would be like, Nick knows that Drake is older than he is. And he also knows that he is older than Cage. He puts those two together and he reasons deductively that Drake is older than Cage. That's deductive. It's absolutely true. There's no doubt about it. And using deductive reasoning requires a couple of laws of logic. The first is the law of detachment. You remember conditional statement written in the language of logic that says if P then Q. So if the conditional statement if P then Q is a true conditional statement and P is true, then we're guaranteed by the law of detachment that Q is true. The conclusion will be true if the hypothesis is true. In the symbols of logic, that's what this says right here. This was on the board the other day. It says if P then Q and P then Q. So if P then Q is a true statement and P is true, then Q is true. Here's an example in words. A conditional statement. If two angles form a linear pair, then they are supplementary. If P then Q. P is two angles form a linear pair. Q, the conclusion is they are supplementary. Angle 1 and 2 form a linear pair. So here is a true conditional statement, and then added to that is a true something that satisfies the hypothesis. Two angles form a linear pair, angles 1 and 2. You can then safely assume, not assume, you can conclude deductively that by the law of detachment, angles 1 and 2 are supplementary. Q must be true. You can conclude that. And that's the law of detachment. The second law of logic that we'll use is called the law of syllogism. The law of syllogism takes several conditional statements. First, if P then Q, and the second, if Q then R. If those are both true, then you can make this leap from P to R. If P then Q and Q then R, then if P then R. Notice that Q is the conclusion of the first conditional, and it is the hypothesis of the second conditional. That's the link that must be in place. In the symbols of logic, it looks like this confusing mess, but it says if P then Q is true, and if Q then R is true, then if P then R can be concluded. In words. Remember Nick, he reasoned that if Drake is older than he is, and he is older than Cage, then Drake is older than Cage. The key idea here is that how old Nick is. Drake is older than Nick, and Nick is older than Cage. So Nick's age was the conclusion of the first and the hypothesis of the second. Sometimes we refer to the law of syllogism, or at least I do. It's like the transitive property of logic. Remember the transitive property. If A equals B and B equals C, then A equals C. And so this is much like that. B was the linking item in the transitive property. Let's move to an example using deductive reasoning, one of the laws that we just learned. If Mike visits Alabama, then he will spend a day in Montgomery. If Mike spends a day in Montgomery, then he will visit the Civil Rights Memorial. Can you draw any conclusions, valid conclusions, from these two statements? Now let's see how this works. Let's let the following clauses represent these P, Q, and R. Okay. The hypothesis of the first statement is Mike visits Alabama. The conclusion of the first statement, Mike spends a day in Montgomery. But that is also the hypothesis of the second statement. And the conclusion of the second statement is Mike visits the Civil Rights Memorial. So we have it set up just right for the law of syllogism. Since if P then Q is true, if Mike visits Alabama, then he spends a day in Montgomery. That's true. And if Q then R is also true, if Mike spends a day in Montgomery, then he will visit the Civil Rights Memorial. So you can conclude by the law of syllogism that if Mike visits Alabama, then he will visit the Civil Rights Memorial. That's what I hope you grew. Okay, let's have a look at another series of examples. I'm going to put up a couple of statements here, and I don't know if there's a way to recall these. I haven't found a way to show a split screen, but let's see. The 5 statements I have are: if a bird is the fastest bird on the land, then it is the largest of all birds. If a bird is the largest of all birds, then it is an ostrich. If a bird is a hummingbird, then it is the smallest of all birds. If a bird is the largest of all birds, then it is flightless. And if a bird is the smallest bird, then it has a nest the size of a walnut half shell. So what I'd like you to do is study these 5 conditional statements and see if you can use one of the laws or use the law of syllogism to construct at least one or as many new statements, true conclusions that you can. So take a moment and write as many true conclusions as you can make. Well, the first one that jumps out at us is statements 1 and 2. If a bird is the fastest bird on land, then it is the largest of all birds. And that conclusion is the same as the hypothesis of statement number 2. If a bird is the largest of all birds, then it is an ostrich. So using statements 1 and 2, you could conclude if a bird is the fastest bird on the land, then it is an ostrich. That's one of them. A second statement would use statements number 1 and number 4. Again, the conclusion here, the largest of all birds, is now the hypothesis in number 4. So using that transitive step, we can use the hypothesis of 1 and the conclusion of 4. If a bird is the fastest on the land, then it is flightless, would be a true statement. And then we also have the conclusion of number 3, the smallest of all birds, is also the hypothesis of number 5. So we have that transitive link right there. So we could have stated using statements 3 and 5, if a bird is a hummingbird, then it has a nest the size of a walnut half shell. So there were 3 true statements you could make. That is all. Next, we're going to take a look at 2 statements, and then I'm going to give you a third statement. And you're going to determine if that third statement follows from the first 2 by the law of detachment or the law of syllogism, or you could say the statement is invalid. None of the laws are applied, and you can't make that conclusion. Okay, it's false. So let's see how that works. Statement 1, if a polygon is a square, then it is a rectangle. Statement 2, figure ABCD is a rectangle. Statement 3, ABCD is a square. Determine if this is by the law of detachment, the law of syllogism, or if it's invalid. Well, it turns out that this is an invalid statement. In number two right here, I'm giving you something that satisfies the conclusion, not a hypothesis. The law of detachment, the second statement would have to be something that satisfies the hypothesis and not the conclusion. So that's an invalid statement. Let's try again. If you build it, they will come. If they come, we'll have a party. If you build it, we'll have a party. Is this a valid conclusion, and which law is at play? Let's see how you did. Okay. This is a valid statement. Number 3 is valid, and it is the law of syllogism, or more or less the transitive property of logic. Okay. One more. All crustaceans have a rigid exoskeleton. A sea turtle has a rigid exoskeleton. A sea turtle is a crustacean. Law of detachment, law of syllogism are invalid. Well, it helps to put the statement in if-then form. The first statement is not an if-then form, so the hypothesis and the conclusion are sort of muddled. Let's see what that would look like as an if-then statement. If a creature is a crustacean, then it has a rigid exoskeleton. A sea turtle has a rigid exoskeleton. So once again, statement 2 is something that satisfies the conclusion of the original conditional statement. So this one would be invalid. Statement 3 is invalid. Let's try again. All crustaceans have a rigid exoskeleton. A Dungeness crab is a crustacean. A Dungeness crab has a rigid exoskeleton. Law of detachment, law of syllogism are invalid. Well, based on that last example, we see that that original statement needs to be in if-then form. If a creature is a crustacean, then it has a rigid exoskeleton. Now, statement number 2 is a statement that satisfies the hypothesis. A Dungeness crab is a crustacean. So then we can make the conclusion that Q is also true. Then, if I give you a P that's true, that satisfies the true conditional statement, and P, then we can conclude Q. It has a rigid exoskeleton, so this was valid by the law of detachment. And so I hope this is enough for you to get through your assignment tomorrow. I'll see you in class, and you get your practice. Good job.